like a MacBook one lag.
It needed
It's
an
the school
update.
Wi-Fi.
The iMovie needed an update last time. So then I updated it and then I had to film it again. Yeah. This time I opened it up during first period instead of waiting until it was time to be used so I can find out if there's an update. Alright, 8.6 is proportions in similar triangles. Okay. Now, we do have 4 new theorems here. I would say 2 of them are easy, and 1 of them is a little bit more difficult, or excuse me, 2 of them are a little bit more difficult. And the first 2 I think you'll breeze through pretty easily. Okay, the first one is called triangle proportionality.
Shall we put out new ones? Yeah, sheets.
Pardon?
We have a new sheet.
Yeah, if you bring me your pink sheet. Okay, triangle proportionality says if a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Okay, I'm not going to write that out because I think that's a little bit confusing. And you guys can if you want to, but I do want you for sure to have the diagram. Okay. So the diagram of this theorem looks like this. It has another line here. Let's go ahead and make sure I got this drawn nicely. Okay. And these 2 lines are parallel. Okay. So AD is parallel to BE. Okay. Now a lot of us have wanted to do something like this in the past, okay, but be careful. This theorem only works if these lines are parallel. If you don't know those lines are parallel, this theorem does not work. Okay, so just be careful with that. Okay, so if AD is parallel to BE, then that means that CB over BA is equal to CE over ED. So let's compare this. Before we really talk about this, let's talk about what we used to say. Okay, in the past, we would have had to compare BC, which is the side of my smaller triangle. What would I have had to compare BC to? What's the side of my big triangle? AC. So I'd have had to compare BC to AC. And that would be okay because it's 2 sides of the triangle, right? Okay, and then I would have compared EC to DC. You guys agree with that?
Yes.
Okay. We don't have to do that anymore if we have parallel lines. If these lines are not parallel, do we still have to do this?
Yes.
Yes. Okay, but if these 2 lines are parallel, we don't have to do this anymore. We can now compare BC to AB and EC to ED. Okay, that's okay now if the lines are parallel. Okay, now, could I also, okay, so they did CB to BA. Could I have done CB to CE and then AB to DE? Yeah, that's okay. Could I have done AB to CE? No, they don't have anything in common. Notice BC and EC, those are okay because they're both on the same triangle, right? Okay. BC and AB are okay because they're both on the same side. Okay, but is there any relationship between AB and EC? No, there's no relationship there. So make sure we're not comparing those two sides. Okay. Questions on this, sir? Okay, we'll do some examples here in a second. The next one is the converse of triangle proportionality. So if we're finding the converse, okay, without even looking at the theorem, okay, let's just look at this conditional statement right here. If AD is parallel to BE, then CB over BA is equal to CE over ED. Allison, what is the converse of that? Okay. Give me 1 second while I write that. If CB over BA equals CE over ED, then what? Good. Then AD is parallel to BE. Okay, you're just flipping it around. So instead of knowing that the lines are parallel, what are we going to do? We're going to prove or find that they are parallel. Am I still going to have the same diagram basically then?
Yes.
Yeah. Still going to have the same diagram. But in this case, we don't know that those are parallel. Make sure I label everything right here. Okay, so here we might be given some side lengths, and we might be trying to find out whether those sides are similar. Okay, so if I come over here, I'm actually going to do this in purple so you can see it better on the video. Okay, and I have just the same diagram here. Okay, with a line. I'm going to say that this is 6, this is 3, this is 8, and this is 4. I want to know, are those lines AB and BC, or excuse me, AB and CD, is AB parallel to CD? Okay, Aaliyah says yes. How'd you figure that out, Aaliyah? Okay, so you did 3 over 6, which is what? Okay, so we reduced that one to 1/2. Okay, and the other one was what? 4 over 8, which reduces to 1/2. Is 1/2 equal to 1/2?
Yes.
So are they proportional? Yes, they are. If they are proportional, then that means what, Aaliyah? My lines are parallel. Good. So there's an example of when the lines are parallel. And let's do a couple examples here. We'll do examples 1 and 2 out of the book. Okay. I have this triangle, a line here. It shows that they're parallel. Actually, I'm going to draw this a little bit bigger. That way the people on the video can see it better. Parallel, parallel. This is 4, this is 8. This is 12. I have A, B, C, D, and E. My goal here is to find the length of AB. What does AB equal?
Wait, so is it okay?
Now, MJ, since those lines are parallel, what can we set up? First of all, if I want to know AB, what am I going to put in for AB? X, good. And then what do we want to set up? 4 over 8 equals X over 12. Now, Kate, is there another way to set this up? Could have done 4 over X equals 8 over 12. Okay, and then even with both of these, we could have flipped both, right? We could have flipped everything. And so there's actually 4 ways to set it up. Are we going to get the same answer every way? Okay. Adriana, could I have put 4 over 12 and X over 8? No. Okay, 4 and 12 have nothing in common, so don't put those together. Okay, so let's go ahead and solve MJ's way. Can I do something before I start solving? Reduce. What's 4 over 8 reduced to? 1/2. So when I cross multiply, I get
12 over 2.
12 equals
2x.
2x. X equals
6.
6. Good. Okay, would I have got the same on the other one? Okay, so what is my answer here for AB equals blank? 6. Okay. Now, in the past, okay, you don't have to do this way. And that was pretty quick and easy, right? In the past, I would have done 4 over X equals 12 over what? 12 plus X. Okay, that's going to be a little bit longer, right? Okay, so hopefully you guys are seeing with the parallel lines, it's making our life a little bit easier. And we don't have to do quite as much work. Would you still get the same answer?
Yes.
Yeah, you're still going to get the same answer for X. All right, it's just going to take you a little bit longer. If you have parallel lines, go ahead and just set up an easy proportion with only one variable. Questions on that example? All right, let's do another one with the converse. Not a very good triangle. I have a line here, AB. I want to know if it's parallel to CD. So I want to know, is AB parallel to CD? Okay. With my art skills, it definitely doesn't look parallel. Okay, but I have 56 here, I have 48 here, I have 21 and 16. Johnny, for those two lines to be parallel, what would have to be true?
Two on the sides would have to be proportional.
Right, my sides would have to be proportional. So set up a proportion here for me, Johnny, that should be true.
56 over 21
56 over 21
equals 48 over 16.
should equal 48 over 16. Good. Okay. Now, again, are there other ways you could have set this up? Yeah, there's 4 ways you could set this up. Okay, when I reduce this, is there something I can reduce out of 56 and 21?
7.
A 7, so 56 divided by 7 is
8.
8 over 3. Can I take something out of 48 and 16?
Yes.
What? A 4. So I have a 12 on top and a 4 on the bottom. Okay, Kelsey, can I reduce 8/3? No, I can't reduce that, but can I reduce 12 over 4? Yeah, so 8/3 is the same. What'd you get for 12 over 4, Kelsey? 3 over 1, good. So Jocelyn, are those the same? Is 8/3 the same as 3 over 1? No, those aren't the same, I agree. Okay, so, are my lines parallel then?
No.
No, they are not. Okay, so my lines are not parallel. Okay, so just set up your proportions and you'll be able to tell whether your lines are parallel or not based on the converse of triangle proportionality theorem. Questions on that one? I think those two theorems were pretty easy. You guys agree with me on that? Okay. The next two are a little bit more confusing. Okay. Next theorem, our goal here is just that when we give them names, is just to give them names where we kind of understand what's going on. Okay, so I'm going to name this one 3 parallel lines intersect 2 transversals. I know it's kind of a long name, but when you read that, what's happening in the diagram?
3 lines are intersecting.
3 parallel lines are intersecting 2 transversals. And that's the goal, is to make sure we understand at least what's happening in the diagram. Okay. This one says, if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. The nice thing about this theorem is the diagram to this is going to be obvious every single time. Because this is the only theorem we have that has a diagram that looks anything even close to this. Okay, so I have 3 parallel lines intersecting 2 different transversals. If that is the case, then AB to BC is equal to DE to EF. Is everybody seeing my proportion, how I got that set up? AB to BC is equal to DE to EF. Again, with proportions. Is there multiple ways to set this up?
Yes.
Yes. What's another way I could have compared those sides? AB over DE equals BC over EF. Claire, could I have done AB over EF? No. Okay. Notice AB and BC are okay because they're on the same line, okay, on the same side. Okay. AB and DE are okay because they're between the same 2 lines. AB and EF are not okay. They're not between the same 2 lines, and they're not even on the same transversal, so they have nothing in common. Okay. Does everybody understand those proportions? I think we're getting pretty good with proportions. Okay. Again, your diagram is going to look very similar to this every single time. Okay, so don't get confused. If it doesn't look anything like that, then you're not going to use this theorem. Okay, but if it looks anything even close to that, you're probably going to use it. Okay. All right, the next one is a ray bisects angle of a triangle. So what's going to happen in these type of diagrams? Array's going to bisect an angle of a triangle. Is that loud?
No.
Alright. If a ray bisects an angle of a triangle, then the opposite sides of the or let's just say opposite sides are proportional to the other two sides of the triangle. How am I going to know if this ray bisects that angle? How am I going to know that? Allison? How? With congruent marks, with our tick marks, right? So it's going to be marked like that? Okay, good. Now, it might also just tell you, or it might say that AB is a what?
Array.
What kind
Angle
of bisector? It might say that it's an angle bisector. Okay, so if it says that, then we know it's an angle bisector. Okay. If this is the case, then CB to BD, okay, so CB to BD is equal to CA to DA. Again, other ways to set this up. Yes, Kate, what's another way to set this up? Good, we could do CB over AC equals BD over AD. Good. Questions on either of those two theorems? Alright, let's take a look at a couple examples. What theorem am I going to use? Three lines intersect two transversals. Okay, and I have 9, 15, and 11. I have 9, 15, and 11. Okay, I want to know what is the length of AB. What is the length of AB? First of all, Evan, if I'm trying to find AB, what should I put in for it?
X.
X. So let's put an X in. That's X. Can you set this proportion up for me?
9 over 15 is 7 over x.
9 over 15 equals 11 over x. Good. Could I have done 9 over 11? Yep. Okay. First step here, solving this. Cross
no,
multiply.
reduce.
You could reduce first. You're going to get the same answer both ways, right? I would reduce. So I get 3 over 5. So when I cross multiply, I get 3x equals 55. What's x equal? 55 over 3. Good. Can I reduce that? Nope. There we go. Questions on that one? Okay, not bad. The hard part's recognizing when to use it. Okay. Next one. What theorem am I going to use? Ray bisects an angle. Okay, I have 9. I have 15. And this whole side over here is 14. This one's a little bit trickier here. I want to know the length of DC. I want to know the length of DC. So Brooklyn, if I'm looking for the length of DC, what should I put in for DC?
14 minus x.
Close. If I'm looking for DC, then DC should be the what variable? If it's unknown.
Oh, x.
By x, good. Okay, x. Okay, so there's my x. Now back to what you were thinking of, okay? First of all, I know that I need to know what two sides in this theorem. I need to know DC and I need to know DB. So Brooklyn, we're back to what you said first. What's the length of DB? 14 minus x. Okay, how did she get that, Gary? Not quite. Drew?
Because in order to find dB, you have to have the other half of x.
Right, so you're saying this whole thing's 14, right? And that little part's x. So this must be whatever's left over after x. Yep, so 14 minus x, good. Okay, so now set this proportion up for me, Bailey.
9 over 15
9 over 15.
equals x over 14 minus x.
Careful, can I put x on top? If you put 9 on top?
Switch it.
There you go. 14 minus x over x. Again, multiple ways to set this up, right? Okay. First step in solving this, reduce that to 3 over 5 again. X times 3 is
3x.
3x.
70.
5 times 14 minus x is what, Thomas?
It's 70.
7, just 70?
70 minus 5x.
Good. 70 minus 5x. Make sure that 5 goes to both. Okay. Now what, Emma? Add 5x. Good. So that goes away, right? On this side I have 8x equals 70. What's x equal? 70 over
8.
Okay, now, can I reduce that? How do you know?
Because it's an e.
Right, they're both even numbers. So what can I take out of two even numbers, Ricky?
You can take out 2.
A 2. So x equals what then?
35
Good.
over 4.
Can I reduce that anymore?
No.
So now we're done. Okay, so those two examples both gave us fractional answers. Do you suppose you're probably going to have some fraction answers in your assignment? Yeah. Okay, so just make sure we can reduce our fractions and stuff like that. Now I didn't do this one with the last class, but I do want to do it with you guys. We got time? Okay, so let's get through this problem real quick. Come out of page. Okay, so I have this triangle. This is example 6. I have this is 7.5, and it's parallel to this. This is x right here. This whole thing is 37.5. And then I have 9, 13.5, and y down here. I need to solve for all of my variables. Okay. What proportions can I set up? And you might have to do more than one here. Hey, Thomas, what's one that you see?
You could do 9 over 13.5.
Okay, so Thomas is doing 9 over 13.5.
Is
Now, can you do that if those lines were not parallel? No, but they are, so you're okay.
and then 7.5 over y. Wait, oh,
We don't want to do that one.
so it'd be 37.5 minus x.
Good.
over
37.5 minus x, which is going to be this segment right here, over x. Good. Okay, so then you would solve that out. I'm not going to go through and solve it because I know we know how to solve our proportions, and we've done plenty of those today. How am I going to figure out what y is, though? This is where we got to be a little careful. We're going to combine not only what we did today, but what we've been doing. Aaliyah?
Would it be 13.5 over whatever you find x to be equals 7.5 over y?
I want to make sure I'm not turning this wrong. Be careful here. Okay? Y is the what? What can you think of y as? The whole base of that big triangle, right? Okay? So what can I compare it to? I can compare it to the whole base of the small triangle. Then what, Kate?
It would be 13.5 plus 9
Right.
over.
So now we're going back to ways we used to solve it. Okay, the whole base of the big triangle over the whole base of the small triangle needs to be compared to the whole side of my big triangle, which is, what's 9 plus 13.5? 22.5 over the whole side of my small triangle, which is 9. Okay, so be very, very careful when you get to these problems. Okay, you're going to have 2 problems where you have to do stuff like this and solve for multiple variables. Be very, very careful on what you're setting up. Okay, because if you're setting up the whole side to the whole side, and then you're not doing the whole side, and you're using x is just part of the side, and it's not going to work. Okay, make sure we're doing whole side to whole side. Okay, we did the whole base to the whole base. We need to do the whole side to the whole side. Just be very careful with those. Okay. On page 502, we need to do 11 through 30. And 34 through 37. We're going to skip the proofs for today. Page 502, 11 through 30, 34 through 37. I know you guys don't have a ton of time to work on that, but let's work until the bell at least. If you do get confused, you can go back and rewatch this video. It will be on YouTube. Okay, so if you just go to YouTube and search my name, you can go to my channel, and it'll be labeled as 8.6. If you have questions on any of those examples.